Let's do Brahmanad. Om. Om. Santi. 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 Swasta. Good morning student. Previous class I discussed about the molecular orbital diagram of some molecules and I also discussed about the postulates of Hesper theory. Now I am going to discuss some molecules and their shapes. Before going to discuss about the shape of molecule, it is bound to remember this table. Suppose the central atom of a molecule having two electron pair, then the geometry of the molecule is linear. If the number of bond pair is 2, number of lone pair is 0, then the shape of molecule is also linear. Shape of molecule is also called structure of molecule. We can write here structure or shape of molecules. There is a difference between geometry and shape of molecule. In case of shape of molecule, we generally consider about the bond pair, but in case of geometry, we generally think about the both bond pair and lone pair. Suppose there are two electron pair and the two electron pair are present in the center of the molecules. Suppose my hand is the central atom, these two are present like this, then this is said to be linear shape. The two electron pair must be away from each other to maintain the minimum repulsion. That's why the molecule wants to stable. If these two electron pair are bond pair, there is no lone pair, then the shape and geometry of the molecule is same. Take examples, that is your BF2, CO2, etc. Suppose a molecule having 3 electron pair, then the geometry of the molecule is trigonal planar. Suppose you have 3 electron pair, then it is bound to arrange the 3 electron pair like this to maintain the minimum repulsion. The bond angle is 120 degree. In case of linear, the bond angle is 180 degree. Among the 3 electron pair, suppose the 3 electron pair are bond pair, there is no lone pair, then the shape of the molecule is also trigonal planar. Example is BX3, GAX3, etc. This is the shape of trigonal planar. Among the 3 electron pairs, suppose 2 electron pair are bond pair and 1 electron pair is your lone pair, then what is the shape of the molecule? There are 3 electron pairs are present like this. Suppose this is your lone pair, then the shape of the molecule is V shape. Look at that, this look like V, so it is said to be V shape. ଯେତେବେଳେ ଆମେ geometry କଥା କହିବା ସେତେବେଳେ lone pair କଥା ଭାବିବା. ଦେଖ lone pair ରହିଲେ trigonal planar ହବ. lone pair କଥା ଯଦି ତମେ ନ ଭାବିବ ତାହେଲେ V shape ହବ. ମନେ ରଖ ପିଲେ, geometry ବାହାର କଲା ବେଳକୁ lone pair bond pair ଉଭୟ ଦୁଇଟାକ ମିଶିକି ରହିବା ଦରକାର. shape ବାହାର କଲା ବେଳକୁ lone pair ର କିଛି ଆବଶ୍ୟକ ପଡ଼ିନଥାଏ. Suppose a molecule having 4 electron pair, then the geometry of the molecule is tetrahedral The bond angle is 109.5 degree. Among the 4 electron pair, suppose 4 electron pair are bond pair, there is no lone pair, then the shape of the molecule is also tetrahedral. The examples of the molecule which having V shape are SnH2, PbH2, SO2. Your X means halogen element, that is your fluorine, chlorine, bromine, iodine. The examples of molecules which having tetrahedral shape are CH4, CH4, NH4 plus, etc. Among the 4 electron pair, suppose 3 electron pair are bond pair, 1 electron pair is lone pair, then the shape of the molecule is trigonal pyramidal. The examples are NH3, PH3, etc. Look at that, there are 4 electron pair are there. Suppose I want to arrange the 4 electron pair in such a way that to maintain minimum repulsion, then it can able to form tetrahedral. This is your said to be tetrahedral. Suppose among the 4 electron pair, this is your lone pair, then the shape of the molecule is your trigonal pyramidal. Look at that, when I will join this point to this point, and this point to this point, and this point to this point, then it make a triangle and the upper part look like a pyramidal. So the shape of the molecule is said to be trigonal pyramidal. Suppose among 4 electron pair, 2 electron pair are bond pair and 2 electron pair are lone pair, then the shape of the molecule is V shape, or it is also called angular shape. The example of V shape are H2O, F2O, HCl2, etc. Look at that, this is your tetrahedral geometry. Among the 4 electron pair, suppose these 2 electron pair are lone pair, then the shape of the molecule is your V shape. Remember an important point, when we think about the geometry, then it is bound to think about these 2 lone pair and these 2 bond pair, then it look like a tetrahedral. But when I want to think about the shape, then it is not necessary to think about these 2 lone pair, only think about these 2 bond pair. Now these 2 bond pair look like V shape, so the shape of the molecule is V shape, or it is also called angular shape. Suppose a molecule having 5 electron pair, then the geometry is your trigonal bipyramidal. Suppose these are the 5 electron pair. To maintain the minimum repulsion, these 5 electron pair must be arranged like this. This is your said to be trigonal bipyramidal. Look at that, this is your trigonal. When 4th number electron pair present like this, then this is your said to be trigonal pyramidal. When 5th number electron pair present below like this, then another pyramidal will be formed. So this is said to be trigonal bipyramidal. Here the angle is 90 degree, another angle is 120 degree. This angle is 90 degree, this angle is 120 degree. This angle is also 120 degree, but this angle is 90 degree. Among the 5 electron pair, suppose all electron pairs are bond pair, there is no lone pair, then the shape of the molecule is also trigonal bipyramidal. Look at that, the shape of the molecule is also look like this. In this case, the geometry is equal to the shape because here all the electron pairs are bond pair. There is no lone pair present in this molecule. The example is PCl5. Suppose among the 5 electron pair, suppose 4 electron pair are bond pair and 1 is your lone pair. Suppose this is your lone pair, then the bond pair are present like this. We know that this is your tetrahedral, but the bond pair are present like this. This is one type of tetrahedral, but the tetrahedral is not regular, so it is said to be irregular tetrahedral. Regular tetrahedral means this is your regular tetrahedral. The bond angle is your 109.5 degree, but the irregular tetrahedral is look like this. Here 4 bond pair are present like this. If you think about, there is also another lone pair is present in this molecule. So when we think about the 5 electron pair, then the geometry is your diagonal bipyramidal. But when we think about 4 bond pair without this lone pair, then the shape of the molecule is your irregular tetrahedral. Example of this molecule are SF4, SCA4, etc. Suppose among the 5 electron pair, 3 electron pair are bond pair, 2 electron pair are lone pair, then the shape of the molecule is your T shape. Look at that, this is your trigonal bipyramidal geometry. Suppose I want to think about this is your one lone pair and this is the second lone pair, then remove these 2 lone pair from this trigonal bipyramidal, then the geometry is converted into T shape. So we can think about the shape of the molecule is T shape. Look at that, this look like a T, so the shape is said to be T shape. But remember, when these 2 lone pair will be attached to the central medulla atom, then the geometry is said to be trigonal bipyramidal. The example of T shape molecule is ClF3, Br, F3, etc. Suppose among 5 electron pair, 2 electron pair are bond pair and 3 electron pair are lone pair, then the shape of the molecule is linear. Look at that, this is your trigonal bipyramidal geometry. Suppose this is your one lone pair, this is your second lone pair, this is your third lone pair, then this look like a linear shape. So the shape of the molecule is linear. But when 3 lone pair are present like this, then the geometry is said to be trigonal bipyramidal. The example of linear shape molecule is HCF2, ICl2-, etc. These are the examples of linear shape molecule in which there are 2 bond pair and 3 lone pair. Suppose a molecule having 6 electron pair, then the geometry of the molecule is octahedral. Suppose these are the 6 electron pair, then the 6 electron pair are arranged in such a manner that they maintain the minimum repulsion and maximum stability. 4 electron pair are arranged like this, and the 5th electron pair are arranged like this, and the 6th electron pair are arranged like this. Now this is your said to be octahedral shape. The bond angle is 90 degree. This bond angle is also 90 degree. This bond angle is also 90 degree. This is your said to be octahedral geometry. If all the electron pairs are bond pair, that means means the molecule having 6 bond pair and 0 lone pair, then the shape of the molecule is also octahedral. That means in this case all the electron pair are bond pair. So here the shape of the molecule is same with the geometry of the molecule. Example of octahedral molecule are SF6, SeF6, TF6, PCl6-, PF6-. These are the example of octahedral shape. Suppose among the 6 electron pair, 5 electron pair are bond pair and there is 1 lone pair, then the shape of the molecule is square pyramidal. Suppose this is your octahedral geometry. Suppose this electron pair is your lone pair. Then remove this lone pair. Now look at that. The shape look like square pyramidal. This is your square planar. When the fifth electron pair is present like this, then it gives also a pyramid. And this pyramid look like a square pyramid. So the shape of the molecule is square pyramidal. Example of this are IF5, BR5, CLF5, etc. Suppose among the 6 electron pair, 4 electron pair are bond pair, 2 electron pair are lone pair. Then the shape of the molecule is a square planar. Look at that. This is your octahedral geometry. Suppose this is the first lone pair. Remove this. This is your second lone pair. Remove this. Now look at that. This look like a square planar. So the shape of the molecule is your square planar. When we think about these 2 lone pair and this 4 bond pair, then the geometry look like an octahedral. The example of square planar are XeF4, ICl4-, etc. Suppose a molecule having 7 electron pair, then the geometry of the molecule is pentagonal, bipyramidal. Suppose these are the 7 electron pair, then the 7 electron pair arranged in a pentagonal bipyramidal geometry. That means I can arrange the 5 electron pair like a pentagonal. When the 6th number electron pair is present like this, then it is said to be pentagonal pyramidal. When the 7th number electron pair present like this, then it is said to be pentagonal bipyramidal. One pyramidal is formed by this electron pair and this 5 electron pair. Second pyramid is formed by this electron pair and this 5 electron pair. Now it looks like pentagonal bipyramidal. This is your said to be pentagonal bipyramidal geometry. Suppose among the 7 electron pair, all the electron pair are bond pair. That means there are 7 bond pair. There is no lone pair. Then the shape of the molecule is also pentagonal bipyramidal. The example of pentagonal bipyramidal is IF7. Suppose among the 7 electron pair, 6 electron pair are bond pair, 1 electron pair is lone pair. Look at that. This is your pentagonal bipyramidal. Suppose this is your lone pair, then this look like an octahedral, but the octahedral is not perfect. This is one type of distorted octahedral. So the shape of the molecule is distorted octahedral. Actually, the regular tetrahedral is look like this, but when we remove this lone pair, then the 6 bond pair are present like this. The angle is not 90 degree, so it look like a distorted form. So this shape is called distorted octahedral. Here this angle is not 90 degree, this is not also 90 degree. This is said to be distorted octahedral shape. The example of distorted octahedral molecules are Xc, F6c, IF6c. These are the examples of distorted octahedral. Remember this table, where it is very easy to predict the shape of any one of the molecule. Suppose I want to explain about the shape of BF2 molecule. How can I know the shape of BF2 molecule and what is the diagrammatical representation of this molecule? In BF2 molecule, the central atom is beryllium. Its atomic number is your 4. Its electronic configuration is your 2,2. So the number of valence electron present in the beryllium atom is 2. Now the 2 fluorine atom attached with the beryllium atom by 2 single bond. As a result, these 2 fluorine atom share 2 electrons for the formation of 2 single bond. Beryllium ର valence electron ହେଲା 2. ଦୁଇଟି fluorine ଅଛି, ତେଣୁ ଦୁଇଟି fluorine ଦୁଇଟି electron share କରିବେ, ତା ଅର୍ଥ ଏଠାରେ ମୁଁ 2 add କରିବି, totally କହିବା ଅର୍ଥ 4. Beryllium ର 2 electron ଦୁଇଟି fluorine ଅଛି, ତେଣୁ ଦୁଇଟି electron add କରାଗଲା, ତେଣୁ total ହେଲା ବର୍ତ୍ତମାନ 4 electron. ଗୋଟେ electron pair କହିବା ଅର୍ଥ ଦୁଇଟି electron को ବୁଝେଇଥାଏ. ଚାରୋଟି electron ନେଇକି ଆମେ 2 electron pair କରି परिबा. 2 electron pair अर्थ चारोटी electron. एटारे pair कहवा अर्थ 2 को बुझेइଥାଏ. In BF2 molecule there are 2 electron pair. दीटा electron pair पिले BF2 molecule रे अछि. वर्तमान दीटा electron pair को हमें दुईटी bond pair करिया को बाध्य. कम पाई पिले मनकर सपोज ये होला beryllium, गोटे fluorine गोटे electron pair द्वारा bonding हवा, आउटे electron pair द्वारा आउटे fluorine bonding हवा. तेणु मन रख पिले BF2 molecule रे दुईटी electron pair अछंती. से दुईटी electron pair मध्यरु दुईटी जाक तार bond pair lone pair हमर किछि नहीं. यदि दुईटी इलेक्ट्रॉन पेयर रहे ताले तार ज्योमेट्री हबो बिले लिनियर. यदि दुईटी बॉन्ड पेयर जीरो लोन पेयर रहइबो ताले तार शेप हबो मध्य लिनियर. ई जो शेप ऑफ द मॉलिक्यूल हमें केमति डिटरमाइन करबा बाय द हेल्प ऑफ प्रीवियस टेबल. इस संपर्क रे हम जो टेबल विषय स्टडी करले ते टेबल को नै हम देखिबा. दुईटी इलेक्ट्रॉन पेयर मध्य दुईटा का बॉन्ड पेयर और जीरो लोन पेयर थले तार शेप ऑफ लिनियर. तेणु आमे एठारे जो दुईटी बॉन्ड रखी छे से दुई बॉन्ड को आमे लिनियरली अरेंज करिया पड़ियो. तामाने आमे बॉन्ड एंगल 180 डिग्री मेंटेन करिवा पड़ियो. वर्तमान देखो BF2 मॉलिक्यूल रो शेप बा स्ट्रक्चर होची लिनियर. इतंगो एग्जाम रे क्वेश्चन में जरा व्हाट इज द ज्योमेट्री ऑफ BF2 linear, what is the shape or structure of BF2 also linear. In this type of molecule 2 bond pair are present and there is no lone pair, so this type of molecule is considered as AB2 type molecule. Here A is the central atom, B is the bond pair. There are 2 bond pair are present, so here I can write B2. So this type of molecule are generally considered as AB2 type molecule. Now I want to explain about the shape of BF3 molecule. In BF3 molecule, the central atom is your boron. The atomic number of boron is 5. The electronic configuration is your 2, 3. From the electronic configuration, it is clear that there are 3 electrons present in the valence shell of boron. Here 3 fluorine atom is attached with the boron through 3 single bond. So 3 fluorine atoms have 3 electrons. So here I can add 3 electrons. Now there are 6 electrons are present. 6 electron means 3 electron pair. Since there are 3 fluorine atoms attached with the boron, so the 3 electron pair are considered as bond pair. That means it is concluded that there are 3 electron pair. Among the 3 electron pair, 3 bond pair, and there is no lone pair. So the geometry of BF3 molecule is trigonal planar, and the shape of BF3 molecule is also trigonal planar. That means it is bound to arrange the 3 bonds like this. This is the trigonal planar shape of BF3 molecule. Here the angle is 120 degree. Since there are 3 bond pair, so BF3 belongs to AB3 type molecule. Now I want to explain about the shape of NH3 molecule. In NH3 molecule, the nitrogen is the central atom, which having atomic number 7. The electronic configuration is 2, 5. There are 3 hydrogen atoms are present, so it is bound to add 3 electrons with the 5. Now there are 8 electrons are present. 8 electron means 4 electron pair. Among the 4 electron pair, 3 electron pair are said to be bond pair, because here 3 hydrogen atom attached to the nitrogen atom, and the remaining 1 electron pair is said to be lone pair. That means the total number of electron pair equal to 4, total number of bond pair equal to 3, total number of lone pair equal to 1. Suppose think that this is your 3 bond pair and this is your 1 lone pair. Then the electron pair are arranged like this. If the electron pair are arranged like this and the bond angle is 109.5 degree, then it is said to be tetrahedral. In the lone pair lone pair bond pair repulsion is more than bond pair repulsion. So these bonds are squeezed and it is able to form another type of geometry, that is your distorted tetrahedral geometry. Here nitrogen atom is present, here lone pair is present like this, here one bond pair is present like this, here another bond pair is present like this, the third bond pair is present like this. किंतु हमको डायग्राम करिया गले एमती बेंड करके देखै था, किंतु सेमान हम यदि एमती जॉइन करिवा ताले कैन एबल टू फॉर्म ए tetrahedral, and this tetrahedral is said to be distorted tetrahedral. Here the bond angle is 107 degree. In regular tetrahedral the bond angle is 109.5 degree. Due to the presence of this lone pair, the bond angle is squeezed. As a result, the new bond angle is 107 degree. In this type of molecule, there are 3 bond pair, 1 lone pair. Here the central atom suppose consider as A. Then this type of molecule is said to be AB3L type. This is all about the structure of NH3 molecule. Now I want to explain about the shape of water molecule. In water molecule, the central atom oxygen having atomic number 8, the electronic configuration of oxygen is 2,6. From this it is clear that the oxygen atom having 6 electron in the valency shell. In water molecule there are 2 hydrogen atoms are present, so it is bound to add 2 electron with this 6 electron. That means there are totally 8 electrons are present. 8 electrons means 4 electron pair. Among the 4 electron pair, it is bound to 2 electron pair are bond pair and the remaining electron pair are lone pair. It is clear that there are 4 electron pair are present. Among the 4 electron pair, 2 electron pair are bond pair and 2 electron pair are lone pair. Since there are 4 electron pair are present, so the geometry of water molecule is tetrahedral. On the other hand, since there are 2 bond pair and 2 lone pair are present, so the shape of water molecule is bend shape. I can draw the diagram like this. This is your one bond pair. This is the another bond pair. Here 2 lone pair are present like this. Here the lone pair repulsion is more as compared to the lone pair bond pair and also as compared to the bond pair and bond pair repulsion. Due to maximum repulsion, these lone pair away from each other. That's why these bond pair closer to each other. And the bond angle is 0.5 degree. The bend shape is also called angular shape. Here 2 bond pair are present and 2 lone pair are present. Suppose your oxygen is said to be the central atom A, then the molecule undergoes Ab2L2 type. It is clear that water belongs to Ab2L2 type molecule. Next I want to explain about the shape of methane molecule. In methane molecule, the central atom is carbon. The carbon having 6 atomic number and its electronic configuration is 2,4. Here 4 hydrogen atoms are present, so it is bound to add 4 electron with this 4 electron. That means there are totally 8 electrons are present. 8 electrons means 4 electron pair. Among 4 electron pair, all the electron pairs are bond pair. That means here there is no lone pair. It is clear that there are 4 electron pair. Among the 4 electron pair, all are bond pair. There is no lone pair. Since there are 4 electron pair, so the geometry is your tetrahedral. Since there is no lone pair, so the shape or structure of CH4 molecule is also tetrahedral, which is equal to the geometry of CH4 molecule. I can draw the tetrahedral structure of CH4 like this. This is your tetrahedral structure of methane molecule. Here the bond angle is 109.5 degree. These bond pair present in the space like this. Since there are 4 bond pair are present, there is no lone pair, so the molecule is Ab4 type. This is all about the shape of CH4 molecule. Next I want to explain about the shape of SF6 molecule. In SF6 molecule, the central atom is sulfur. It has 6 electrons in the valency shell. There are 6 fluorine atoms, so it is bound to add 6 electrons with this 6 6 valence electron. That means there are totally 12 electrons are present. 12 electrons means 6 electron pair. Among the 6 electron pair, all are bond pair. There is no lone pair. That means it is concluded that there are 6 electron pair present. Among the 6 electron pair, all are bond pair. There is no lone pair. Since there are 6 electron pair, so the geometry of the SF6 molecule is octahedral. Since there is no presence of lone pair, so the shape or structure of SF6 molecule is also octahedral, which is equal to the geometry of SF6 molecule. I can draw the octahedral shape of SF6 molecule like this. Here one fluorine atom is present, here another fluorine atom is present. The angle is your 90 degree. Here 6 bond pair are present, there is no lone pair. So this type of molecule belongs to Ap6 type molecule. This is your octahedral geometry or shape of SF6 molecule. Here sulfur atom is present, here one fluorine atom, here another fluorine atom, here third number fluorine atom, here fourth number fluorine atom, here fifth number fluorine atom, here sixth number fluorine atom are present. Next I want to explain about the shape of PCl5 molecule. In PCl5 molecule, the central atom is phosphorus. It is seen that the central atom phosphorus having 5 electrons in the valency shell of phosphorus. Here 5 fluorine atoms are present, so it is bound to add 5 electrons with these 5 electrons. Now totally 10 electrons are present. 10 electron means 5 electron pair. Among the 5 electron pair, all are bond pair because here 5 fluorine atom is attached to the phosphorus atom. There is no lone pair. It is concluded that there are 5 electron pair are present. Among the 5 electron pair, all are bond pair. There is no lone pair. Since there are 5 electron pair, so the geometry of PCl5 molecule is trigonal bipyramidal. TBP means trigonal bipyramidal. Since there is no lone pair, so the shape or structure of PCl5 molecule is also trigonal bipyramidal, which is equal to the geometry of PCl5 molecule. I can draw the trigonal bipyramidal structure like this. Here phosphorus is present, here one fluorine atom, here another fluorine atom, here third number fluorine atom is present. This look like your trigonal. The angle is your 120 degree. The fourth number fluorine atom is present like this. Here another fluorine atom present like this. This angle is 90 degree. Look at that. Here phosphorus atom is present. Here one fluorine atom. Here another fluorine atom. Here another fluorine atom. Here fourth number fluorine atom is present. Here fifth number fluorine atom is present. This is the trigonal bipyramidal structure of PCl5 molecule. In PCl5 molecule, there are 5 bond pair are present. There is no lone pair. Suppose the central atom is your A, then PCl5 belongs to AB5 type molecule. Next, I want to explain about the shape of IF7 molecule. Here the central atom is iodine. It is seen that the central atom iodine have 7 electrons in the valency shell. Here 7 fluorine atom is attached to the iodine, so it is bound to add 7 electrons with these 7 electrons. atom are present in IF7, so it is bound to form 7 bond pair. That means there is no lone pair. It is concluded that there are 7 electron pair. Among the 7 electron pair, all are bond pair. There is no lone pair. Since there are 7 electron pair, so the geometry of IF7 molecule is pentagonal bipyramidal. Since there is no lone pair, so the shape or structure of IF7 molecule is also pentagonal bipyramidal, which is equal to geometry of IF7 molecule. I can draw the pentagonal bipyramidal structure like this. This is your pentagonal bipyramidal structure of IF7. This bond angle is 90 degree, but this bond angle is 72 degree. This is the pentagonal structure of IF7 molecule. Here iodine is present and all the positions are occupied by 7 fluorine atom. Here this angle is 90 degree, but this angle is 72 degree. Since in the IF7 molecule there are 7 bond pair, so IF7 molecule belongs to AB7 type molecule. Next I want to explain about the advantages of Vesper theory. First point, it clearly explains the shape of every small molecule, anion and cation. Second point, it explains the electronic configuration of the element present. Third point, it gives importance on the lone pair of electron in determining the geometry of molecules, anions and cations. These are the advantages of Vesper theory. Next I want to explain about the disadvantages of Vesper theory. First point, it cannot be applied to the transition metal complex where incomplete d orbital are involved. Second point, it cannot explain the shape of isoelectronic species. These are the disadvantages of Vesper theory. This is all about Vesper theory. Thank you. Have a nice day.